Hi, welcome back to Math 111. We're going to continue our discussion of section 1.2 by taking a look at symmetry. Now, I've copied here the table, the box from page 26 of your textbook that talks about testing a function for symmetry. And I want you to understand what we mean by symmetry. And in this course, all we're worried about is symmetry about the y-axis and symmetry about the x-axis, or symmetry about the origin. Those are the only things we're going to test for at this point in the class. Okay, so let's just talk about this. Let's take a look at a couple of functions. Let's take a look at the function y equals x squared. And you can see that this function mirrors itself across the y-axis. There are mirror points. So if I looked at, for example, x equals 2, the function goes through the point 2, 4. It also goes through the point negative 2, 4. Oops, sorry. Negative 2, 4, right? And the same could be said of 1, 1, and negative 1, 1, and 3, 9, and negative 3, 9. So this function mirrors itself across the y-axis. So it is symmetrical about the y-axis. Sorry, I keep saying function. This is a function, but you don't know what that means yet. This relation mirrors itself, is mirrored across the y-axis. Let's look at another relation. Let's look at x equals y squared. This is a perfectly valid relation. And this one is mirrored across the x-axis. If x is 4, y could be 2 or negative 2. If x is 16, y could be 4 or negative 4. Okay. Now let's look at y equals x to the third. And let me see. Yes, this function is symmetrical about the origin. Now what that means is that you have to, in order to make this one make sense, we kind of have to talk about, if I fold it along the line y equals x, if I take my graph, if I printed this out, and I folded it along these two red dashed lines. So in other words, if I folded it down and then folded it over, my graph would lie right on top of itself. That means symmetrical about the origin. Okay? So think about folding along both axes. Fold down over the x-axis and then fold along the y-axis. And your graph will lie right on top of itself. That's what it means to be symmetrical about the origin. Now, how do you test that? It's one thing to look for it visually, but how do you test it? Well, let's just take these three functions, or these three relations, and follow what this box says. So let's start with the relation y equals x squared. This says substitute negative xy into the equation and simplify. Okay, so I'm going to test for symmetry about y-axis. So y, I'm substituting, I'm replacing y with y and negative x with x. And now I'm going to x with negative x. And now I simplify. This is the same as my original. So symmetric about the y-axis. If I test my other symmetries, And you do need to test all of them because it is possible for a relation, think of a circle, to be symmetric to show all of these symmetries. So we're going to test for symmetry, and we know this is going to fail, but I want to show you what this looks like. Test for symmetry about the x-axis. So it's to say, this says replace x with x and negative y with, or y with negative y. So what I'm saying is negative y is equal to x squared. If I solve that for y, or simplify it, I get y equals negative x squared. This is not the same as y equals x squared. So my function is not symmetric about the y-axis. Let's try the origin. And again, we know this is going to fail because we know what this function looks like. But we're going to do it anyway. Symmetry around the origin says to replace x with negative x and y with negative y. So we're simplifying negative y equals negative x squared. We're going to simplify this. We get negative y equals x squared, which simplifies to y equals negative x squared. Again, this is not the same as y equals x squared. So my relation y equals x squared is not symmetrical about the origin. Okay? So that's your basic technique for testing for symmetry. If you're asked to test for symmetry, this is what we want you to do. And a function can have symmetry, well, a relation can have symmetry about the y-axis, symmetry about the x-axis, symmetry about the origin, or none of these. So let's take a look at an example from your text. Let's just do this example. We're going to look at the relation x minus 2 squared plus y squared equals 1. And we are going to test this guy for symmetry. Okay, so test for symmetry. About the x and y axes and about the origin. Okay, so let's start with symmetry about the y-axis. My table tells me to test for symmetry about the y-axis, I'm replacing my x's with negative x's and leaving y's as y's. So negative x minus 2 squared plus y squared equals 1. Now the question is this the same as what we started with? And we're going to have to do a little work here. So we got to simplify this. If I square this first binomial out, what I get is x squared plus 4x plus 4 plus y squared equals 1. Okay, now looking at just these x's, I know that that factors as x plus 2 squared plus y squared equals 1. That is not the same as my original x minus 2 squared plus y squared equals 1. So, no symmetry about y axis. Okay, let's move this to another page. Okay, so we don't have any symmetry about the y-axis. Let's test for symmetry around about the x-axis. So my box tells me that to test for symmetry about the x-axis, I want to leave my x's as x's and plug in negative y instead of y. So I'm going to test to see if x minus 2 squared plus negative y squared equals 1. We're going to simplify that. Okay, we can leave the x minus 2 square. We don't need to do anything with that. Simplify the negative y squared, we just get y squared. Ooh, that is the same as my original. So this relation is symmetric about the x-axis. Okay, let's check for symmetry about the origin. My box tells me I'm going to replace negative x, or x with negative x, and I'm going to replace y with negative y, and I'm going to simplify. So I'm trying to simplify negative x minus 2 squared plus negative y squared equals 1. And we're trying to see if that matches my original. So do the same thing I did before. And this gives me x squared plus 4x plus 4 plus y squared equals 1. Again, I know that these x's, that trinomial, factors as x plus 2 squared plus y squared equals 1, which is not the same as what we started with, which was x minus 2 squared plus y squared equals 1. So no symmetry about the origin. Okay, so that's how you test a relation for symmetry. I hope this has been helpful, and I will talk with you again soon.